Oh, nice. Let's log in again. Hmm, what is it? Which was on the phone? Which was on the... Hmm, talk. 14 not upgraded. Please enter. I don't know what I'm doing. Okay, okay, yes. Yes. At least it's working for me. Yeah, okay. In worst case, during that number of taken the suspension of roasted teeth. And not even call it color at all. The part is start we now have two types of colors and that perfect always for final side. Hmm. So each model will have a black, the root is black. Or Nelly, children of black. Or fastness, someone. All parts from the model go through the same number of black produced in this. Some way inside It for you, so it is we can see other people surrounding us over top and that's a very so so um, we never shouldn't have line right okay that is left side should be on human part of this too. Um, um, this is like like yeah kind of not but that is I don't like whatever. Uh, values equal just return because this value is a uh, we went have that's interesting. But in the to kind oh, good. So being self and that is Masha. Otherwise, compare the values times that is and events. My God, I'm so down. Oh, good. Wow. Oh, I just said, oh, creating efforts like that.
사람 사이 사람 모두 함께 모여서
Oh,
carry on, but I'm not hiding. You grabbing me hard, 'cause you know what you found is biscuits, is gravy bag.
well,
Can't surprise a Gemini, but you know it's biscuits, is gravy babe. I knew you'd come back around, 'cause you know it's biscuits, is gravy babe. Let's fuck in the back of the mall, lose control, go stupid, go crazy, babe. I know I'll be in your heart till the end. You'll miss me, don't baby, babe. It's making you cry every time you give your love to me this way, saying you'd wait for me to stay. I know it hurts you.
Prisma, an open source tool that makes it fun and safe to work with your database. The relational database is ancient technology that has stood the test of time, but writing SQL code is not an ideal abstraction for modern app development. It provides too much low-level control, and you'll probably blow your foot off writing it. To address this concern, ORMs like SQLize implement object relational mapping to express data with object-oriented code like JavaScript classes. Prisma is also an ORM that addresses similar problems, but instead, it has its own declarative schema definition language. You write a schema to express your data and relationships in a human-readable way, or the schema can be automatically inferred from any existing database. Prisma then converts the schema into type definitions, allowing you to perform type-safe CRUD operations with your own database models, which means you get IDE autocompletion tailored to your own custom schema. In addition, it handles migrations as your data structure evolves. And if you want to visualize your data, Prisma Studio allows you to view and manage all of your tables and rows in the browser. To get started, you'll need a relational database like MySQL or Postgres, although MongoDB is supported as well. From a Node.js project, run npx prisma init. This creates a .env file where you can add your database URL and a Prisma directory to define the schema. If the existing database already has data, we can run Prisma db pull to introspect it and automatically generate the schema from it. Notice how each table is represented with the model keyword. Then inside the braces, we have column names and their data types, as well as optional constraints. Like for example, we might use relation to create a foreign key constraint between a weapon and a human, and we can also index the weapon ID while we're at it. The beauty of this is that the code is significantly more concise than what you would write otherwise in raw SQL. Now, if we decide to modify our schema, like add an extra timestamp column, we'll also need to modify the database structure, which can be handled automatically with the Prisma migrate command. Now, to interact with the database on the server, we tell Prisma to generate the client library, import the client into a JavaScript file, and notice how it autocompletes the models in the schema. If you do something wrong, you'll know about it right away. Now find all the humans with the find many method. To filter the results, we can add a where clause as a plain JavaScript object. And if we want to join a related table, we can do that by adding the include object. Prisma already knows how to run the complicated SQL code under the hood and returns the data as an array of JavaScript objects ready to use in your application. This has been Prisma in 100 seconds. If you want to see more short videos like this, Supabase, a complete backend for web and mobile applications based entirely on free open source software. The biggest challenge when building an app is not writing code, but rather architecting a complete system that works at scale. Products like Firebase and Amplify have addressed this barrier, but there's one big problem. They lock you into proprietary technology on a specific cloud platform. Supabase was created in 2019 specifically as an open source Firebase alternative. At a high level, it provides two things. On the back end, we have infrastructure like a database, file storage, and edge functions that run in the cloud. On the front end, we have client-side SDKs that can easily connect this infrastructure to your favorite front-end JavaScript framework, React Native, Flutter, and many other platforms. As a developer, you can manage your Postgres database with an easy-to-understand UI, which automatically generates REST and GraphQL APIs to use in your code. The database integrates directly with user authentication, making it almost trivial to implement row-level security. And like Firebase, it can listen to data changes in real time while scaling to virtually any workload policies to control who has access to your data. In addition, the database supports triggers to react to changes in your data and Postgres functions to run stored procedures directly on the database server. It's a nice interface, but it also automatically generates custom API documentation for you. From here, we can copy queries tailored to our database and use them in a JavaScript project. Install the Supabase SDK with NPM, then connect to your that JavaScript code from the API docs, or use the REST and GraphQL APIs directly. And that's all it takes to distribute it around the globe. This has been Supabase.
Hi everyone, we'll break down a powerful way to store.
Let's understand how a red-black tree works. A red-black tree is a special type of self-balancing binary search tree in which each node can be either red or black. The leaf nodes, commonly referred to as nil nodes, are considered black by default. Now, a red-black tree has 5 key properties that are essential for maintaining its balance. First, we have already discussed that every node are either red or black. Second, the root node should always be black. Next, the nil nodes are always black. Furthermore, if a node is red, both of its children must be black. This means that a red node cannot have a red child, which prevents 2 adjacent red nodes from existing in the tree. Lastly, every path from a node to its descendant nil nodes must contain the same number of black nodes, ensuring that the tree remains balanced in depth. For example, let's consider this node with value 5. If we follow the path to the leftmost leaf node, we find there is only one black node in that path. Now, if we follow the path to any other leaf node in the tree, there will also be exactly one black node along the way. This demonstrates that the property of having the same number of black nodes in every path from a node to its leaf nodes holds true in this tree. This balance is what ensures the efficiency of operations in red-black trees. Now, keeping this property in mind, it's quite apparent that the height of the tree should be at most twice the black height. The black height is defined as the number of black nodes between the root and any leaf node, not including the leaf itself. Since there can be alternating red and black nodes in any path, the total height of the tree can be no more than twice the black height. Additionally, the number of nodes in a red-black tree should be at least 2 to the power black height minus 1. This is because the black height represents the minimum number of black nodes along any path from the root to a leaf. In the best case scenario, where every level alternates between red and black nodes, the tree can have the fewest possible nodes while still maintaining its balance. This lower bound ensures that even in the most compact arrangement, the tree has a significant number of nodes relative to its height. By solving these 2 equations, we can determine the maximum height of a red-black tree. The height can be no greater than 2 times the logarithm, base 2 of n plus 1. This means that as the number of nodes increases, the height of the tree grows logarithmically, ensuring that the tree remains balanced and efficient for operations like search, insertion, and deletion. Now, let's take a look at the code for the node class. We will begin by defining the class node.
Hello there, my name is James and welcome to this in the intro. I don't want you to take any break. I know exactly what's going on here. And the first concept I'm going to introduce you to is known as the full stack. Now when you open up your computer, load up a browser and come to YouTube, essentially the course. Alrighty, you know what they say? With the theory done, the fun may now begun. That's a good one for you. Now, it's time to dive into Chapter 2, which is our first practical introduction to backend development.